Hi, in this video, I'll show two different ways of solving a mixture problem. First, I'll show the traditional algebra method. Second, I'll show a way using proportions, or more specifically, balancing the proportions. And at the end, I will give a proof that the proportion balancing method works. So a mixture word problem is a kind of word problem where items or quantities of different values or percent concentrations are mixed together. Sometimes different liquids of different percent concentrations are mixed together, resulting in a liquid with a new concentrations. Sometimes it's quantities of different dollar values are mixed together, or investment accounts of different return rates are mixed together. They're all approached the same way. So let's take an example. Pharmaceutical company has a container of cough syrup that contains 20% active ingredients and another container of cough syrup with 40% active ingredients. They want to mix 30 gallons of a new syrup with 25% active ingredients. How much of each should they use? So I need an S right there. All right, so for mixture problems, I like to draw a picture to visualize what's going on. So in this case of a liquid, I draw a picture like I just drew. I have some 20% syrup, and I have some 40% syrup, and they're mixed together into something that's 25% syrup, and we need specifically 30 gallons. And the question is, how much of each do we need? When you read a word problem, you want to understand the scenario, what's going on of things being mixed, what people do with the 20%, what people do with the 40%, and where did the 25% come from, right? You want to understand the scenario. And then you also understand what kind of information you're given and what kind of information you're not given that you need. So in this case, it seems like there's the concentration and the quantity, and they're kind of related. And we have that information for the final product, but we don't have that information for the two components. So that gives us the idea that maybe the quantities of each component should be the unknown variables. And in fact, it is what the question is asking. So I would say there's some X quantity coming in from the 20% on the left, and some Y quantity, some Y gallons quantity of the 40% container coming in from the right. So I'm going to let X be the quantity of the 20% syrup in gallons, and let Y be the quantity of 40% syrup. All right, now the traditional algebra method. To do the traditional algebra method, you need to realize two things. Number one, the overall quantity must add up. And number two is that the amount of the stuff inside also must add up. The overall quantity, you have X coming in from the left, you have Y coming in from the right, and it makes 30 gallons. So the X, Y, and 30 must add up. X plus Y must equal to 30. And the second thing is that the amount of the stuff inside must add up. The stuff inside in this case is the active ingredients, and there's 20% of it coming in from the left, 40% of it coming in from the right, and it must make 25% of the 30 gallons. The active ingredients must add up. So it's the 20% from the left plus the 40% of the Y must add up, must be 25% of the 30 gallons. So let me zoom out so you see the picture. 20% of the X coming in from the left, 40% of the Y coming in from the right, and it must be equal to the 25% in the mixture. That tells us that 0.20X plus 0.40Y must be equals to 0.25 times 30, or you can simplify it as 0.2X plus 0.4Y is equal to 7.5. So you have a system of equation. One is about the total quantity, and the other is about the amount of the stuff inside. For most people, this step was the hard step. So by the time you get the two equations, you're basically home free. Of course, you still need to solve it either by elimination or by substitution. I'll solve by substitution, and I'll speed up the video. You can press pause to follow more closely if you want. That was the traditional algebra solution. Now the proportion balancing method. In the proportion balancing method, we look at this problem as trying to balance the percent. We have 20% of the X coming in from one side and 40% of the Y coming in from the other side. And it's still true that X plus Y is equal to 30. Now we want these two, 20% and 40%, to balance out at 25%. Since the balance point is over to the left, basically we sort of know ahead of time that we need a bigger amount of X and a smaller amount of Y. The proportion balancing method works like this. This distance here from the left end to the balancing point has a difference of 5%. The difference on the other side has a difference of 15%. So the 5% of X must balance the 15% of Y. You can write it with or without the percent symbol. It doesn't matter. One is just 100 times the other. So what this says is 5X is going to have to be equal to 15Y. Like I said, you could also write it in decimal form. 0.05X is equal to 0.15Y. And then if you multiply by 100 both sides, then you'd get the same thing. Either way, you end up with X is equal to 3Y. And I know that X plus Y is equal to 30. So that means equal to 3Y plus Y is supposed equal to 30. So that tells you that 4Y equals to 30 and Y is equal to 7.5. And X is equal to 3Y, so it's 3 times 7.5, and it's 22.5. So 22.5 gallons of the 20%, 7.5 gallons of the 40%. Same answer as before. All right, let's do again with another example. Mom invests $20,000 into two accounts. One account is expected to pay 3% interest, and the other is expected to pay 8% interest. And mom wants to have an overall return of 7%. How much should mom invest in each account to reach her goal? So you read it and you make sure you understand the scenario. And for this case, some people got stuck on the fact that why would mom want 7% when there's an 8% account available? Why doesn't mom want to get filthy rich and go for the 8% and forget the 3%? Good question. And the idea is, in money matters, it's generally true that the high return involves high risk. So when you are putting your money in for savings, you want to, what people call, diversify your investments. But that's a question for another course. for us is given like this. So we have some 3% accounts and some 8% accounts. So we're going to have this balance beam again. So it seems natural to define, let X be the money in the 3% account and Y be the money in the 8% account. Then it's still true that X plus Y is equal to 20,000. That's all her money. All her money is going into these two accounts. All right, now we're going to use the balancing method. Well, we want to balance out at 7%. So we're going to compute the difference again. The difference here is 1. And the difference here from 3 to 7 is 4. And you can work with percent as a decimal, or you can just work with the number 4 and the number 1. And X is on the 3% side and Y is on the 8% side. The 4X must balance the 1Y. So that gives me Y is equal to 4X. I substitute that in here. I get X plus 4X is equal to 20,000, meaning 5X is equal to 20,000. X is equal to 4,000. Y is equal to 4X, so that's 16,000. So the final answer is 4,000 in the 3% account and 16,000 in the 8% account. All right, let's double check with the traditional algebra method. And again, I'm going to zoom through really fast. And you can pause the video if you want to slow down. All right, let's take another example. This one is a little bit different. A coffee company wants to mix 50 pounds of coffee beans worth $1 a pound to some amount of a second kind of coffee beans worth $10 a pound to make a mix worth $7 a pound. How much of the second kind should they use? Again, we have this one is $1 and the quantity of it is 50 pounds. This one is $10 and the quantity of it is not known. And we want to balance out at $7. Sorry, $7, not 7%. $7 at some quantity that's also unknown. So it seems natural that we should define this. I'm going to call it Y. This quantity is, well, you got 50 from this side and you got Y from this side, so it's 50 plus Y. Let's consider this difference here and this difference there. This difference here is $6 and this difference here is $3. So the balancing is that the 6 of the 50 must balance with 3 of the Y. Wait, we have our answer already. This says 3Y is equal to 300. So Y is equal to 100. Again, the traditional algebra method, $1 times 50 pounds plus $10 times Y pounds has to be equal to $7 times the 50 plus Y. Okay, the dollar values must balance. And Y is equal to 100. In summary, number 1, draw the balance beam. Percent value with the quantity and a percent value here with the quantity. This percent value could be percent value or price. And the balance is somewhere. The balance is given as either P price or P percent and with some quantity. Compute the difference or distance in percent or price from either end to the balance. So I compute this difference. So it's P minus P1 here. And I compute this distance, which is P2 minus P. And number 3, the difference times quantity on the left must equal the difference times the quantity on the right. And then to combine that with information you know about total quantity with the equation about the total quantity. And then you can solve for the whole thing. This is the complete method. All right, so now let me prove that it works. So let's say I have a situation where some P1% of quantity X goes into a bucket, some P2% of some quantity Y goes into the bucket, and they end up with P%, and the quantity is, of course, X plus Y. All right, so on the left, I'm gonna do the proportion method. So I have P1 here, have P2 here, have X here, I have Y here, and I want it to balance out at P. So the proportion method says, first, I'm gonna take this difference, so that's P minus P1, and then I'm gonna take that difference, that's P2 minus P, and I multiply by the quantity. So on the left, the quantity is X, on the right, the quantity is Y. So difference times the quantity, difference times the quantity. So that's the proportion method. The algebra method is I take P1%, so that's P1 over 100, times X plus P2%, so that's P2 over 100, times Y, and I get P%, so that's P over 100, times the quantity, which is all of X plus Y. All right, so first of all, I'm gonna multiply both sides by 100, so all the denominators go away. And second of all, I'm distributing that P, so I end up with P1X plus P2Y is equal to, and distribute, I get Px plus Py. All right, I'm going to move all the Y's to one side and on the X to the other side. P2Y minus Py is equal to, Px is already on the right side, and I subtract P1x both sides to get it to the right side like this. And if I factor out y on the left here, I get P2 minus Py, and I factor out x on the right, I get P minus P1x. And it's the same equation as using the proportion method. So that's proof that the proportion method and the traditional algebra method are the same thing. All right, hope that helps. Thanks for watching. Bye.